Hello, today we're going to start lesson 3.3 and it's entitled Intercepts. The goal of today is to be able to identify the x and y intercept and interpret their meanings. So by the end of class today, when you leave here and someone asks you outside of class, what did you learn in class today? You should be able to say, I can find an x and y intercept of a graph and I know what it means. So that's what we're going to do today. So let's jump right in and let's start with our first example, example number 1. In example 1, you're going to be asked to find the x-intercept and the y-intercept of a graph. So let's start by talking about what exactly an x-intercept and a y-intercept is. Let's start with the x-intercept. The x-intercept is where the graph crosses the x-axis. The way I usually try to remember this is by looking at this one word right here called intercept. Can you think of another word that sounds like intercept? When I hear the word intercept, I always think it sounds like the word intersect. And most of us know what the word intersect means. And intersect simply means to cross, so that's exactly what the x-intercept is. It's the place where any line, it can be a straight line, it can be a curvy line, it's any place where a line crosses the x-axis, which means the y-intercept should be virtually the same thing. The y-intercept is where where the line crosses the y-axis. So that's what we know so far. So let's use this to do example number 1. Example number 1 is just like homework problem 3 in your homework assignment. So here's example 1. Identify all the intercepts. Well, let's start with the x-intercepts. We need to find all the places that this blue line crosses the x-axis. We need to find all the places that this line intersects the x-axis. So one of them's here. That point would be -4, 0. It intersects here. And that point would be 1, 0. And finally, it intersects, let's get rid of that line. It intersects here, which would be 3, 0. So those are all the x-intercepts. Now, typically a line that we'll be dealing with will only have one x-intercept. The reason why this one has more is because it's a curvy line, and typically after this example, we won't be dealing with these curved lines. But it is important that you notice something about the x-axis. Look at the ordered pairs over here to the right, -4, 0, 1, 0, and 3, 0. What do all of these x-intercepts have in common? If you said all of them end in 0, you're absolutely right. No matter what, wherever a line crosses the x-axis, the y will always be 0. And that's what this means right here. When you saw that in your notes, that's what it means. At the x-intercept, y is always 0. There's no exceptions to that. So now let's do the x-intercept. The y-intercept. So we're looking for the places where the line crosses the y-axis. And that is the only spot. That's the only spot that this curvy line crosses, or, here's a better word, intersects the y-axis. So let's write this ordered pair down. That would be 0, 2. And though there's only one of these, I want you to notice that the x coordinate is 0, which will always be the case. Whenever you do this on your homework assignment, please make sure to write these as ordered pairs. Now that you've watched this example and written it down, you should be able to do practice problems 1 through 4 in your homework. So pause this video, go do the first 4 examples, and then come back for help with problems 5 through 18. In example 2, we're going to learn a quick way to graph lines by finding the intercepts. So in this example 2, which corresponds to homework problem number 5, we're going to graph the line x minus y equals 4. And we're going to do this by finding the intercepts. Well, like we have done in the past in lesson 3.2, we're going to do this by making a table. Now, typically we have found 3 points, but this is going to be a little bit different. We're just going to find 2 points. So when we're trying to find intercepts, all we have to do is make x 0 and make y 0. And then it's a 2-word process: substitute and solve. So let's do problem number 1. We'll make x 0. So we'll go 0 minus y equals 4. Notice what I've done. I've simply taken our x and I substituted it in for x right there. And now we're going to solve this problem. Well, this x is nothing, so it cancels out. But we have to make sure we drop down our negative y. And if we're left with negative y, we can simply take this negative and move it to that side. So we found it. Y equals negative 4. And what you guys just found is the y-intercept. You just found the y-intercept. So let's find the x-intercept. We're going to do the same thing. We're going to substitute and solve, but this time we're going to substitute it in for y because we made y 0. We're simply substituting and solving. So this 0 is going to go in right there. So here we go. X minus y is now 0 equals 4. Just like before, this cancels out, and we're actually left with our answer. X equals 4. We can now fill in our table, and we will be finished with this part of it. Now that we have our table right here, we can use this to graph it. So let's bring in a graph, and let's graph what we found. And now it's just a matter of plotting our ordered pairs. So let's start with the first one. 0, negative 4. That would be right there. And our next one is 4, 0, which will be right there. And we can finish up by drawing a line through it. And there we go. Notice what's special about these 2 points. Both of these 2 points are on intercepts. Look, this is where it crosses the x-axis, so this is our x-intercept. And this is where it crosses the y-axis, so that's our y-intercept. I'll just make a note of it right here. X-intercept. Okay, next example. Example 3. We're going to do the same thing we just did. We're going to graph by finding and plotting intercepts. So here we go. The equation we're given this time is x equals negative 2y. So we're going to start by making our table. You should have one on your guided notes. We just need 2 columns, 2 rows, And here we go. Remember, on this, it's really easy. We're going to make x 0, and we're going to make y 0, because that's where they cross the x and the y-axis. And we're going to simply substitute these in and solve. Hopefully by the end of the lesson day, you'll find this to be a really, really easy method to do. So let's begin. On our first one, we've got x equals negative 2y. So we're going to substitute in 0 for x, so put a 0 here, equals negative 2y. This is a multiplication problem, so the inverse operation is division. We'll divide both sides by negative 2, divide by negative 2. These negative 2's cancel out. We're left with y equals 0 divided by negative 2 is 0. So there you go. Now hopefully some of you guys notice this and kind of realize where it's at. Some people will see this and they'll think they did something wrong. Don't freak out if you get a 0. Zeros are perfectly fine to get. All we have found out right here is that it's going to cross at the origin. So let's do one more. Let's do our last one. Let's substitute in 0 for y this time. We get x equals negative 2 times 0. And we are practically done. X equals negative 2 times 0 is 0. So let's fill in our table. There we go. So we have a little bit of a predicament here. And the reason why we have a problem is because how many points do we need to graph a line? If you said 2, then you're right. But unfortunately, we don't have 2 points. We just have 1 point. We have the same point twice. So that's not going to cut it. So we're going to have to do something a little bit different on this one since the x and the y-intercept is the same. So I'm going to erase this real quick. And let me show you what we're going to do. What we're going to have to do is we're going to have to find a third point. So let's make our table just a little bit bigger. Give ourselves another column. You won't have to do this that often, but if you do, it's really not a big deal. So you guys can be creative. What do we want to pick? Well, looking at this equation right here, it seems to me that if I put something in for y, that's going to be by far the easiest. So what I'm going to choose to do is I'm simply going to choose to make y 1. I could have chose anything, and I could have even chose something for x. But by looking at this equation right here, it seems that if I pick something for y, it's going to be an easy problem to solve. And since I like things to be nice and easy, that's why I chose this. So let's go up here and write this down one more time. We've got x equals negative 2y. I'm going to substitute this in for y. So x equals negative 2 times positive 1. And last but not least, I get my answer. X equals negative 2. So, do you see why I picked something for y? Because look how easy that was. I just substituted in for y, I multiplied, and I was done. So we've got another ordered pair. There we go. So, we've got enough ordered pairs. Let's bring in a graph, and let's graph this. So here's our graph. Let's go ahead and plot these points. Our first point is 0, 0. Right there. Now, I know our second point also says 0, 0, but that's the same point. So we're not going to use it again. Our next point, the one we had to come up with because the points were duplicated, is negative 2, positive 1. So let's go to negative 2. And let's go up to positive 1. And there we go. We've got 2 points, which is plenty to make a line. And we've got it. Now I want to draw one thing to your attention before we move on. Let's look right here. That's our only intercept. Most lines will have two intercepts. Most lines will. But this particular line was unique. Since it crossed at the origin, there's only one intercept. So what we have to notice is that 0, 0 is both our x-intercept and our y-intercept. And like I said, that won't happen that often. This is a unique case, but it can happen. And if it does, you'll have to add one more line to your table, like we did down here, and you'll have to find another point. Okay, so you've watched two examples. You're actually almost done. You should now be able to do homework problems 5 through 18. It's a lot of problems. So you'll do those 13 problems, and when you get to problem number 19, you need to pause that video and you need to come back, or excuse me, you need to start this video again and come back and see us. So go work on problems 5 through 18 and raise your hand if you have any questions. Okay, our fourth example corresponds with homework problem number 19. And if you're watching this part of the video, you should have your first 18 problems on your homework completed. So this is a word problem, but if you've got to this point in your homework, then you should be fairly comfortable with intercepts by now. So this shouldn't necessarily be that hard. So let's read this problem. The revenue for a particular company's park and resorts, Y, in millions for the years 2002 through 2006 can be approximated by that equation. Now, X represents the number of years after 2002, so that's important. Two things that are important right here. What does Y mean and what does X mean? In word problems, it's important to know what these things mean. So basically, Y is the revenue, which means money. And X are years after 2002. So we've identified these things. It told us this in our word problem, and that's important. So question A, what is the y-intercept? Well, let's write down our equation. We've got y equals 1,381 x plus 6,535. So there's our equation. We like to draw that line down the center. And here we go. If we are looking for y, that's what we're trying to find. We're trying to find the y-intercept. We're looking for y. Then what we have to do is we have to make x 0. If you're looking for y, make x 0. If you're looking for x, make y 0. So let's go ahead and do this. Let's see what we can figure out. X is 0. Okay, I'm erasing this. Let's start over. 6, 5, 3, 5. There we go. Now, since all the numbers are on the right-hand side of the problem, you can just type this in your calculator. But what some of you might notice is that anything times 0 is 0, so those cancel out, and we're left with 6,538. So our y-intercept that we can write right here. X was 0. There we go. Remember, we plugged in 0 for x. And then y is 6,535. We got it. So, again, even though this was a word problem, it wasn't a big deal. They wanted the y-intercept, so we just made x 0 and solved the problem. Part B. Choose the statement that best describes the significance of the y-intercept. Okay, so let's talk about the the real world significance of what the y-intercept typically means. In word problems, if you're dealing with the y-intercept, here's what it means, and I would highly suggest to write this down. The y-intercept almost always means the starting point. I would write that down, I would highlight it, I would circle it. That's what it means. So when it says choose the statement that describes the significance of the y-intercept, what we need to know is that 6,535 is our starting point. That's where it starts. So up here in the problem, let's go back up to this problem real quick. This is what the graph is talking about. So this graph is starting in 2002. So let's glance at the choices real quick and let's see if we can find the best one. A says, in 2002, the revenue for the parks and resorts was $6,535 million more than 2006. No, that's incorrect. It has nothing to do with 2006. Remember, it's just our starting point. So A is not right. B, in 2002, the revenue for the parks and resorts was about $6,535 million. That's the correct choice because 2002 is our starting point and we're starting at 6,535. So that is it. The most important thing I think you should remember on this is just remember that in word problems, in real world problems, y-intercept is typically where we start. So there we go. I'd pause this video. I'd go do problem 19 real quick, and then I'd come back to watch the last example. Raise your hand if you have any questions. Okay, our final example. This is example problem number 5, and it corresponds to homework problem number 20 on your homework assignment. It tells us right off the bat something that we should already know. It says two lines in the same plane that do not intersect are called parallel lines. We know that. So it says draw a line parallel to the line -7. I don't think that's drawn in your notes, so let me draw that for you real quickly. Y equals -7 is right here. And mine's not perfect, but it should have crossed right there at -7. So draw that on your guided note sheet. Now, it tells us to draw a line parallel to this one that intersects the y-axis at 0, -1. 0, -1 is right there. And I really wish I could draw my dots better on this program. So if we want a line parallel to it, then what we'll need to do is we'll need to draw this line right here. And check it out. Those 2 points never intersect. Ever. Ever, ever. They're parallel lines. Now they want us to write the equation of this line. Well, let's notice some things before we get all confused and start just jotting things down. Let's notice some very important things. Does this line touch the x-axis? Will this line ever touch the x-axis? Will it ever touch this line right here? It won't. So if a line does not touch the x-axis, if a line does not ever touch an x-axis, that means there is no x in the problem. There's no x in the equation. There's only going to be a y because it doesn't touch the x. It does not intersect the x. So we can begin knowing that this line will never touch the x-axis. We can start by going y equals. Well, what does y equal? Y equals -1. Y equals -1 everywhere on this line. So again, it's important to realize since this line never crosses the x-axis, there will not be an x in the problem. Let me give you one more quick example. This is going to be very quick. Let's finish up with this. Let's say I drew this line right here, right there, and I asked you to write the equation of that line. Well, again, the first thing you should notice is that, hey, this is a vertical line. This line will never, ever touch the y-axis, ever. And since it won't ever touch or intersect the y-axis, there won't be a y in the problem. So this vertical line would be x equals 9. So that wraps that up. Now that you've watched this example, you should be able to do the last problem in your homework assignment. That's homework problem number 20. If you have any problems, please don't hesitate to raise your hand. You can stop this video and complete your homework assignment.